Hello everyone, let's get back into the course and we would try exploring up to bug 50 in a single video, but let's see how it goes. Over here we are with the 16th bug. That's the Confluence takeover, how a simple support email gave me a full wiki access. The person was testing the system known as company.com, like it's an alias, not a company.com, right? These systems usually have a support email like support@company.com that automatically creates email with the ticketing system. So he just mailed the support@company.com. A few minutes later, he got an email with an invitation to their Atlassian instance. And when he clicked onto that particular thing, the invite, he went into that particular Atlassian server. At the first, nothing seemed so tricky, but the fact that a random email created a user account inside the Atlassian server. So when he accessed that particular thing, the portal has some features that were supposed to be internal and accessible to employees only. He reported this issue, but the issue was marked duplicate, right? But he never stopped. Then he started exploring other things. Atlassian instances often run multiple products under the same domain. So this Atlassian domain looks something like this: target.atlassian.net. So he browsed for Jira servers, browse, admin panel, Confluence spaces. Without any hope, I started typing out Jira admin, but you don't have access to that. After losing hope, he tried to enter this wiki endpoint and it said you don't have access, but it didn't happen. I got the full access to the company's Confluence server, and inside the internal wiki server, there were internal architecture diagrams, configuration, documentation, and it was not now marked as a duplicate because it was a sensitive bug. So he got a 4-digit bounty, and that's why try harder, right? If you got a duplicate, just try to enumerate more and you would be good. Moving to the 17th. This is bypassing 2FA in a public bug bounty program. How it happened was I entered a random OTP and captured the request in Burpsuit's proxy and sent it to the repeater module for further analysis. Instead of forwarding the OTP request, I dropped it entirely. The OTP verification request included a WebJSON token with an authorization header. This was a critical flaw as the JWT appeared to grant access to authenticated endpoints. So what's happening is that the JWT token, which is responsible for authentication, is getting granted in the 2FA flaw itself rather than after the 2FA authentication is done. So he used that authentication. So the request looked like this, but this JWT grants to access to a lot of authenticated things. So what the person thought of that, he got all the parameters which are used post login for authenticated functionality and try using this authorization token, which is technically incomplete because the 2FA is not yet done, but he used this particular thing to do some endpoints and he gained access to all API endpoints. So this was a $4,000 bug. It was easy, yet it was good. After the fix was implemented, he started exploring the functionality again. Everything was fixed apart from this payment order page, and he was able to access this payment order page and do a transaction. So the company gave him 2000 more for finding this particular thing, and the total was a $6,000 boundary. The key takeaway from this particular thing is that the company shouldn't leak the JW token in the 2FA authentication pages. Sometimes it might give access to a lot of authenticated functionalities. When an Android app whispers secret, how it happened is that he was testing a Android app and he was using ADB Logcat to find the logs of that particular mobile app. Let's call it example app. And when he was testing, he found a lot of plain text emails, raw passwords, session tokens in plain text. So by using logcat, right, the test passwords look like this somewhat. So how it worked is that you use a example launch app, enter any dummy credentials and run this command adb logcat for getting the logs out of that particular Android app. And he got this email entered, and session tokens in the form of JWT, which is not a good practice. And yep, that was a bug. And it's the rest of the article is about why you shouldn't store sensitive information. So the key takeaway from this particular thing was that you should not use plain text information in the logs. Another thing, unauthorized privilege escalation in role logic. He was testing a system where there were two types of privileges, one with the admin, one with the owner. So admin has the access of manage user settings with but with some restrictions. Owner has full control, including deleting the organization. In this case, admins were not allowed to delete the organization, but I found a logic flow that admins to assign themselves the owner role without any approval. So how it worked was that create a new organization, invite a second user with the admin functionality, log in as the admin user, go to add people and invite your own account again, but this time as owner. Notice that the invite is automatically accepted on your role is immediately updated. No approval from existing owner is required. So it's like a logical flaw. It's nothing like a bug. The the developers made a mistake in this one. So not now that I'm the owner, go to the organizational settings and delete the organization. So it was like a something that was bad at the developer's perspective rather than anything else. So it was a luck by chance thing. So yeah. OAuth open redirect to account takeover. This is the same lab, I guess. There's a lab on Portugal for this one too. Not, I guess, yeah, there's a lab. So when you use a OAuth endpoint like the Facebook, it looks something like this. Login.redirected Facebook return URL and this particular thing return. So he played with this return URL parameter. He tried these things redacted. It's success when he tried to go to our own web servers to get that particular code. It didn't work, but when he used this mutation like https my server at the rate www.redacted.com, it worked. So it looks something like this, my server. So once you can send this to your own server, you can check the logs of your own server to see the OAuth token in the request. Then you can use this OAuth token to get the session cookie and you would get a full account takeover. So yeah, this was good. I personally liked it a lot. Then moving on to the 21st, I adore how I added my own dishes to a restaurant menu. So the story, there was a program which has two types of users, manager user and a customer user. If you own a restaurant and want to list it on the app, you are a manager user. If you're looking for a restaurant to book for your date or something else, so this is kinky. All right. So I first created a customer user, but there were not many functionalities to look for. Everything was limited until I could book a restaurant. The program prevented testing on real restaurants, so I opened the manager domain and started filling in a fake restaurant. So now the tester is doing some testing on the manager privileges. He noticed a function in my manager account where I could open my menu in three ways: PDF file, menu link, image files. Just a second, guys. Sorry, guys, got an important meeting. So, yep. Getting back to the point. So, I noticed a function in a manager's account where I could upload my menu in three ways. That's PDF file, menu link, and image files. Right. So, I uploaded a PDF file and captured the request. It looked like this. It was a GraphQL endpoint and with a restaurant UUID and yep. So the thing that might have caught his attention was the restaurant UUID. That's a unique identifier. I can created another manager's account and swapped its restaurant UUID with my target restaurant's UUID. However, when I sent it, I received the following response which says unauthorized. I tried the same thing with upload image method, but it returned the same response. I didn't expect that add link method to work either, but I decided to give it a try. I captured the add link request, swapped the UUID, and it worked. I opened my secondary restaurant account and noticed that added link web page was now displaying in the restaurant's menu section. But here's the problem: restaurant UUID is a unique identifier that only the restaurant owner knows. If he can't brute force it, the report would be informative or like NA. So I opened my customer account and interacted with the restaurants in every possible view. Search of restaurant UUID, and then in the add to favorite function, the restaurant UUID was getting leaks. He reported it to bugcrowd, and you get the bounty. That's simple. Next function, same bug, different places. That's bug number 22. No rate limiting, no tokens, no just cookies and three juicy bugs. So how the bug started? He tested no rate limiting on a endpoint to vote players. So he voted once. He tried to vote again. He said not allowed to vote twice. So he started thinking. When he looked at this endpoint, there was a certain thing known as CUID that was responsible for identifying that particular thing. When he changed that CUID value, he got to vote again, and it kept on repeating. The same bug was on reaction on post. So the only identifier that was responsible for the post was CUID, and he could do any rate limiting attacks, right? And then it comes to this particular flaw: business logic, broken wallet, hacked OTP bypass. So how it worked was, there's a website known as redacted.ai. It's a AI based job matching platform. Lets users sign up using email, verify their account using DigiLocker, reward actions with wallet coins, provide virtual assistance and job matching. So he did these bugs, but how exactly everything started? Redacted AI used 4-digit OTPs for login and forgot password flows with no rate limiting, so he could already do the no rate limit attack and gets the right OTP. So that's the first bug. It could result in account takeover or a pre-account takeover. Then it comes to the other flaw known as business logic flaw. So after creating a new account, I explored the wallet feature. A pop-up appeared allowing me to request an amount in dollars despite my wallet balance being $0. I sent request of some dollars. Naturally, I intercepted the request using burp suit, but it says insufficient wallet balance. I changed the 400 bad response to 200 and removed the body of the response and forwarded the request further. To my surprise, the front end accepted this and sent post API update wallet balance. In the update wallet balance, he updated this amount and the type from debited to credited, and he got a balance amount of this much things. Stored XSS in resume, so you could upload a PDF file format which contains an XSS or a SVJ, and it works like a charm. And these are the content types which you could use: image.jpg and image.svg plus XML. Moving on, mobile number verification bypass. It might be related to the code abuse too. On the response, it says success false, error invalid, OTP, but you could change it to success true, and it's bypassed. And it's these are basically very common bugs. The one which I liked was of the increasing balance, to be honest. How I tricked a Swagger UI into showing a fake login page. This one was really good. So he was using Subfinder to find the subdomains of the target, then using HTTPX to see which subdomains are live, then using Katana to get the endpoints. And when he used this, he got this endpoint and a Swagger UI. One DOM XSS is very famous for Swagger UI, but it didn't work. He used XSS.yaml and XSS.json, which were the important components of triggering the XSS, using this endpoint API.target and these particular things, but it didn't work, right? It doesn't allow pop-ups. So he made a phishing POC for login.yaml and login.json and hosted this particular thing in here, and it looked something like this. Now this is a fake login page, but it could be used for phishing or tricking internal team members into entering their credentials. And yeah, this was scary because it could lead to phishing or anything. There were no CSPs, no restrict functionality. HTML was not getting sanitized. It was HTML injection, and it was interesting, but something out of the box. Moving on to the 25th bug. I bypassed 2FA using an old secret. This was one of my favorite when team sent me the list. So he was exploring the functionality. I noticed that enable 2FA didn't prompt the user to re-enter their password. This is a P5 bug. Some companies take it as a P4, but it's a duplicate. Then he logged in into the website, enabled the 2FA using mobile authenticator, disabled the 2FA, logged out of the application, logged back in, and went to enable 2FA. Now, instead of scanning the new QR code, he used the old secret key from the previous step to set up the authenticator and enter the new OTP again. And this was accepted. This is a vulnerability that old secret should be disposed of. It was accepted and reported with a bounty of $500. It was a simple bug for those who don't understand. So here's the flow. So you log in into an account, enable the 2FA, note its secret key, like write down its secret key somewhere else, uh, log out of that account, then log in again, disable the 2FA, enable the 2FA. Instead of scanning the new QR code, enter this secret right here. Enter the secret right here, right? Okay, just a second. All right. Mhm. Enter the secret right here, and yep, enter the OTP which it's showing, and the 2FA is enabled again. It's a bug, right? The old secret should be disposed of. This was really interesting. Moving on to the 26th one, I would try to complete till 15 this video, but let's see how far we can go. How you unlock premium features for free via simple API trick. So always when you test, you make two accounts, one free plan account and one free trial account with some premium features. So when he was digging deeper in the API, he got some requests like post API team current invitations. That is for sending the invitations. I grabbed the authorization token and crafted a simple post request which looks like this. Okay, email what user you want to give, join our team. Then I fired the request. Invite went through successfully. The user was added to the team. Even this account wasn't supposed to have the ability to invite someone. So how they escalated this one is they created two accounts. Bugs like these are pretty confusing for beginners. Account 1, account 2, right? So account 1 is a free account with no privileges. Account 2 is a trial account with certain privileges. On this account, he got a request of invite functionality. He copied that request, got the JWT authorization token, and used it in this request and sent an invite to a user. Now, technically, this invite button was restricted in this free account, but he got the invite button. He used the JWT token from this account and he was able to send invite, resulting in use of premium features. Now why it worked? Because there was a front end validation, there was no proper back end validation. So he reported that bug and he would have got a bounty, right? That's pretty simple how you use these tricks to do that. Then coming to the case, the uppercase escape, breaking endpoint restrictions. So he this one was really funny. So he got a particular target known as example.com API matrices. Now this is a P4 bug when you get the matrices, and it was restricted. Instead of using matrices lowercase, he used matrices uppercase. And he was able to bypass the restriction of that particular thing, and he reported that bug. And yeah, he got the information. So you could do similar for the health endpoint, admin endpoint, debug endpoint, because when the developer doesn't set proper restrictions, things happen, right? This was a really funny one. Why I told this? Because my point of showing you the bugs is that it should open your mind. What could you try, what could you not try? So how I took a website completely offline with a funky cache poisoning vulnerability. This was really interesting, closely with the Portswigger lab. So he was hunting on a target.com, and then he quickly noticed that the site was next.js and was sitting behind a CDN firewall. While poking around, I saw certain paths assets were being cached, like assets images. This is a common directory that always gets cached. My first thought was to try some classic cache deception to leak sensitive information, but I hit a dead end. Nothing seemed to work. Reading research and write-ups is always great. Thank me later, guys. Just joking. So the CDN had some specific rules for caching content. It cached specific paths like target.com, assets, images, and after images, it's pretty much anything, right? It cached popular pages like login and slash. But if the response had 200 status code, if only the login and slash pages showed 200 status code, it only cached it. Then he understood how he can abuse this particular thing to do a denial of service. A normal request in the login page would return a full HTML page as you would expect. But after digging some digging, I found a special header X middleware prefetch. When I added this to my request, the server completely changed. It starts returning an empty page. So when he added this header to the X middleware prefetch as a header into the request, it started showing blank objects. At the same time, you need to notice that this trick only worked if you use HTTP 1.1. If you use HTTP 2, it would load the login page fully, right? Send a login, and so what you do is send a request to login, add the X middleware prefetch. The server responds with a 200 OK and a blank page. The CDN sees a 200 OK and caches this broken response for everyone. Boom, site is down. Plot twist: after more digging, I realized that whenever I visited the site, the server set 3 cookies with seemingly random values. Now it's for the person who has a certain cookies, right? How it works is, just to explain, you go on to the login endpoint, you add that header which gives a empty page but a 200 OK, and caches it and showed it to everyone, but it's all cookies, it's not globally. So for every session the server gives 3 cookies. That's what we are talking about. This was the problem. The CDN wasn't just caching one version of the login page, it was cache created different cached version of the user cookies. This means my poisoned page was only cached for users who had exactly the same cookie values at me. And every time it generates a random set of cookies, my attack was useless against them. So if someone has new cookies, the attack won't work for them. Digging deeper, random isn't always random. So when he researched about this a bit more, and he sent it to Burp Sequencer to analyze the values, this is what he finally found out. They were being picked from a very small predictable list. How it works is, SUG cookies only had one of the 3 values. To analyze the combinations, he used sequencer, so it only had these 3 values. SRC SUG had only these values. BISE had these values. So if we take the combination 3, 2, 2, 6, 12, so there were kind of 12 combinations that could result uh, for the cookies to be generated. So he poisoned all 12 combination of the cookie sets using a Python script and a login page. And for everyone, now it shows a blank page, resulting in web cache deception. And yeah, it's a P1 kind of, so bringing the entire website down. This was really cool bug. I personally liked it a lot. Getting to the 29th, bypassing the group member limit with the race condition. This is very common bug. I have done it a lot of times, but why I included it in my list was that some people might find it fascinating. So in some trial version, you have some limits that you can invite 5 users, 100 users. So after dropping the users to 99, the last request, use burp repeater as a parallel set of requests, send them on once. Like you can use turbo intruder to do that, burp repeater with prepared parallel request. You could do it anyway. So you are able to invite more than 100 users because the concurrency is not properly handled. So it's like abusing things using um, concurrency things, right? Race conditions. Then one more race condition bug is that, let's assume the target is example.com. When creating a new event, the application asks for a event name. If the name already exists, the front end would display a message, name is already taken. So if I have a username, you cannot use the same username. That's how things work. But if you try using a new name, so use a new name, but send this request to burp repeater and make 11 identical requests using it, and send them in parallel single packet attack. So 3 out of 11 succeeded in creating events. So you could create this user's name with same IDs. This could it's basically medium to high bug, and three accounts are created with the same name. But this is something interesting you could use in your daily day-to-day approach, right? Also, same ID, another target got duplicate to triage, right? So yep, that's how it works. But it was a unique bug. I personally liked it because I never tried it in this way. So you always keep on learning. From public sheet to API takeover, how it works was that he was doing a recon, searching engine docs. He got a publicly accessible Google sheet being used as a backend for live data portal. The sheet contains structured tabular data. So he got hard coded private keys for Google Cloud Project private key and everything. So he could use a GCP project by using these API keys. Full column defacement, so he could write any columns in that. He could use those API keys to get the GCP identity access management permission. So basically, when keys are leaked, it could result in very bad things. So it's always good to do some docking. If you find some Google Sheets, spreadsheets, any kind of GitHub repositories, and you believe they are leaking some keys, always try exploring that. How I earned 1752 using just nmap. How it works was, this was a private program or a well-known platform. The scope included a few subdomains and a handful of cloud assets, but he took a different network level recon path. So he used this nmap uh, scans to run on this target.com, and he found this jetty server. On this jetty server, he tried with the admin prompt, right? On the admin prompt, he tried it but didn't reveal anything. Then he went on discovering the robots.txt file. It discovered a backup.zip file. When he clicked on that backup.zip, it included the source code of the admin portal, config files with hard coded credentials, and the env files with AWS keys, resulting into a P1 bug. And he was awarded $1752 for this one bug. And yeah, nmap helps sometimes. I always run nmap scans on my target, to be honest, so it's good. How an API token flaw let me bypass premium restrictions. He was hunting on this particular target. When a new user receives sign up, they receive a 21 days free trial granting access to platform's premium features. So if you take a look at what the backend API request returns, it actually responds with error message saying trial expired. So technically, the system says understands that the trial is over. Since the API was throwing a trial expired message, I started thinking how I can bypass it. So he started looking at the documentation. So when he followed along the documentation, so he got a lot of API requests that would have helped it. So what he did was, now I was thinking where this API tokens could be used. So I went on documentation. I found out they had a CLI program where the API tokens could be used. So I installed the CLI program using Brew. Now that I figured out where the API token could be used, the next logical step was to test how I could interact with the platform using it. According to the docs, the CLI allowed users to do a lot of creating and managing apps. So he even if you are a trial is expired on the website, using their CLI tool, you are able to do a lot of actions that are initially meant to be expired on their website. So it's like a flaw, and it was a VDP, so he didn't. It was he got $200 for this bug, as there is no potential for business impact because a trial account, so that it cannot support a production implementation legitimate issue will which we will fix. So but it was created that you, even though your web account is expired, you could use these API keys tokens on the CLI to do some stuff. So it's good. I personally like that. 34th bug. I guess we would do till 35 in this video. I guess it would be too overwhelming if we do 50 in a single go. He was testing on this target known as app.target.com/fuzz. I couldn't find anything interesting, so I kept searching with Google Docs until I found some path app.target, and this endpoint lead to ctl login.php, and there was a SSO and Azure. When he looked at the JS files using de4js, he found this endpoint ent invite friend bix, which had the utility through an email parameter send registrations to any user. I went to the test endpoint with my bugcrowd email and received an invitation invite. Using this link, I was able to register login as an employee and access privileged information such as name, addresses, phone numbers. It was a $500 bug. So he discovered this endpoint. On this endpoint, multiple JS files were being loaded. He used this tool to analyze the JS files. He got this endpoint from those JS files. He was able to invite himself as an employee, and he got these bugs. So yeah, the people are really great hunters, to be honest. The last bug for this video is massive data leak using unauthenticated ARC gist REST service. So he was using this particular sublister example and getting to see which domains are working or not. So he found one subdomain known as gistexample.com. Upon browsing, it gave him the status code 5503 service unavailable. So as usual, we skipped to next subdomain REST endpoint at GIS server REST services. It showed some things, right? I immediately fired this endpoint, and it was containing ARCGIS 11.1 server REST endpoint. As you can see, it contains different endpoints like countries, utilities. I tried to access country endpoint. It brought to me a login endpoint and gave me 503 service unavailable as below. If you see directory, there is service export CSV as below. Upon exploring, this option brought me to task submitting UI, so that does mean it allowed unauthenticated users. Next, I submitted the task. It generated output in zip file. As this is an insurance company, the output contained massive data of farm profiles like location of farms, third party auditing status. This bug was marked as 7 point high, and I was awarded with bounty specifically. So how it's good to fuzz on such domains so that you can discover stuff. So even if the main page shows 503404 or something like that, it's always good to fuzz. I always get a lot of bounties using this method, and automation is good for these subs. This was all for this video. See you in the next one, guys. Thank you.